Welcome to another episode of the Geotechnical Engineering Podcast. Today, our guest will be John Myers, PE. He's a design manager at Menard Southern Region in the United States. We're going to be talking about the career benefits that come with having a graduate degree in geotechnical engineering. We're also going to talk about, whether or not the expense is justified. When you think about what it costs to go to grad school, is it worth it in the long run? So we're going to talk about that. And today we're going to really delve into that. So looking forward to this conversation. And again, I'm your host, Jared Green, and this is another episode of the Geotechnical Engineering Podcast. But before we get into our episode for today, we want to hear a word from our sponsor today, and that is from Simpson Strong Tie.
Restarting your career when you are over 40 is no joke. But I was welcomed at Simpson, and I found a second family here. When you walk in and you see and you feel the culture at Simpson, it's very warm, it's very inviting. It's nothing like you've ever felt. Having the flexibility to be home gave me the opportunity to not miss anything. Simpson really does see your value. They see the value in everyone who's there.
All right, John, welcome to the show. How you doing?
Good. Glad to be here. Thanks, Jared.
Excellent. I was looking forward to this conversation. Super excited to have you on. And I just said we're going to discuss the benefits of pursuing a graduate degree in geotechnical engineering. This is a hot topic in my world, and I'm sure it is in your world. So looking forward to where we go here, So it would be great if you could introduce yourself, tell us a little bit more about your background and your current role. What is it you're doing on a daily basis?
Yeah, so my name is John Myers. I'm a design manager for the Southern Region at Menard. So that kind of, there's a nebulous border somewhere in Virginia that depends on who you talk to, where that border lands, but kind of wraps the coast over to Texas, plus a couple states further inland. So I manage the design work kind of across that region for Menard. I am currently based in Richmond, Virginia. Prior to that, I was in the Gulf Coast in Houston, Texas, and was there for 6 years. Prior to that, I got my master's and bachelor's degrees in civil engineering at Virginia Tech, with concentration in geotechnical for the master's degree. Day to day is probably a little bit all over the place. I both end up, I manage our design work and our group of designers for the South region, but also work with our bidding and estimating teams a bit to kind of help support the efforts that they're going through and bidding work, and primarily making sure that we don't get ourselves into trouble, trying to get a little bit too aggressive sometimes, but on better days, coming up with cool creative designs that we can kind of use to economize a project.
Excellent. Now, when you were at Tech, just to kind of paint the picture a little more, you did the thesis or non-thesis option for your master's?
I did non-thesis. I had a very, very small bit of just general research that I did with Jimmy Martin, but I don't know that I actually contributed to any real research projects in any significant way.
All good. We do what we have to do to get that degree, right?
Yeah. I got a couple credit hours out of it.
No, that's good. All right, cool. And it sounds like you moved around quite a bit in the South, in Southeast. So that's awesome.
Yeah. I came back from Houston about 2 years ago. Yeah, 2020. Time runs together. Yeah.
Excellent. So in your opinion, what are some of the advantages of pursuing a graduate degree in geotechnical engineering?
Yeah. So the thing that, I think I'm still kind of coming to terms with it in some respects, but I think you go to school for engineering, right? And you kind of start out you're in engineering, and then you go into civil engineering. You kind of think that as like sort of a specialty. And then you get to civil engineering, like I want to do geotechnical, and you kind of view that as a specialty. Mm-hmm. And I think what you don't really realize, especially in undergrad for sure, and I don't even know I really realized it for the first couple of years of working, is you get to geotechnical engineering, and then you could go out into 10, 20, whatever different specialties, even from there, like mine tailings, or, you're doing dams and seepage analysis, or, seismic site response, pick your textbook. And I don't think you have any sense of that really coming out with just an undergraduate degree. So you could get a job and you can go work for a company and you'll be exposed to what they do or what that group does. but you're not going to have that sort of broader understanding of all those different things that really make up the field and tying them together in kind of interesting and cool ways depending on what projects you're working on.
Yeah, you're absolutely right, and it's interesting. I mean, we have we'll focus on the West. That's where we are, right? It's like even after you have that advanced degree, you start working and you're in one part of the country where you have expansive soils, you go somewhere else, you have seismic activity, another one you're on fault zones, somewhere else you have carbonate rocks, in some places you have it's like there's so many different things that depending on where you are, that you then have another subset or specialization that you kind of need, right?
Yeah, going from Houston and like the Gulf Coast and doing a lot of work in like South Louisiana to the Mid-Atlantic and like the Piedmont region. Yeah. The idea that you don't have a bearing layer in South Louisiana, it's just clay for forever. And people are like, wow, we need to get these settlements like down to an inch. It's like, no, you don't. You'll be fine if it settles 2 inches. It might make you a little bit uncomfortable, but as long as it's uniform,
yeah,
all right.
and that's
every day.
Exactly. You've been doing it for a while, right? It is when we say settlement, right? It's like it depends on where you are, right? Like I have plenty of projects, folks like yourself, where we got a subway next door, and you got to have less than 1/4 of an inch, right? But you're right. If you don't have anything surrounding you, if you don't have anything that can't go for the ride, if your building goes for the ride and the structure says that it's okay and it's uniform, then who cares how many inches or millimeters it's going? So it really does depend. And I guess if you have an undergraduate degree, you don't really specialize in geotech. You maybe had 2 classes depending on what university you are. You I guess you're limited in what you could specialize in as you go further along in your career,
it's going to be tied to who did you end up working for and what did you learn from them a lot. You maybe pick up a lot of specialty from the person that you're working for, but you're kind of at their mercy a little bit. So you really hope you have a good engineer that you're working for and you can learn under, because you don't have that broader experience you can kind of bring in.
Yeah, no, makes sense. So I'm sure as you as well, I interview a lot of candidates when I'm hiring. I go to career fairs. I hear this question come up a lot. Would you recommend pursuing a master's degree immediately after completing undergraduate, or would you take the route of doing a few years, gaining some work experience, and then returning to school? And if you return to school, do you return full time, or do you do it like at nights and weekends? So that's like a 3 or 4 parter there if you're counting. But what are your thoughts there? I know what my answer has been. Curious to hear what yours is there.
Yeah, so I don't have a set answer that I would tell people. I can give some things to think about, right? Okay, so I think when you go from undergrad into grad school, it's a little bit of a natural, there's no life change there, right? You're living that student cheap, not really making money life. You probably don't have a wife and kids or husband and kids or that you're, wrangling and trying to support and all that. So that transition is maybe a little bit easier. That said, you don't have a sense of industry to be able to bring, real world things back and apply it. And I think, and I went straight through from undergraduate into the grad program.
Same.
Yeah. So, and this is a little bit of a side. So I'm heavily involved with the CGPR at Virginia Tech, and they do a presentation kind of every year of like enrollment figures. And what they've shown is that when the economy drops, people go into grad school and vice versa. And that was exactly what I did. I graduated undergrad in 2011. Things weren't quite, recovered from financial crisis, and it was all right. The job prospects aren't as amazing. Let me go into grad school.
Yeah.
But you don't have that, broader industry experience to bring it back in. So I think if I had a couple of years working, I think I would have been a better student. That said, going straight from undergrad into working, you miss out on some of the stuff that you might be able to bring from a grad program. So whichever one you do first, the one you do second will benefit.
Yeah, that's a good way to think about it. Yeah.
But if you do go to work for a little bit, you kind of have to take into, think about the fact that, hey, if I work for 4 or 5 years, all right, maybe I'm now in my late 20s or later in my 30s, have you settled down a little bit at that point? And to your nights and weekends comment, that maybe is what you have to do, unless you can kind of convince your family, whoever's with you, that hey, we're gonna take a hit for a couple of years. I'm gonna get this full-time grad school thing, and we'll budget a little bit better and do all that.
Ramen noodles and tuna fish, right? It's like
Yeah, the thought of doing a PhD has crossed my mind once or twice, but
okay.
I don't think my wife would go for it.
Okay, got it. Yeah, it's fascinating because there's so many different ways to do it, right? And I think a lot of it ties back to what you just said, and then the situation that's at hand, right? Like if you're an undergrad and you know a professor there, and a professor says they'll give you a fellowship and they're going to pay for it, and then it's like, all right, now I have to spend a year and a half or a solid year to do this. It's paid for, as opposed to if I go work for someone and then I'm doing it, company's paying for it, now I have to return to the company, not sure if this is the company I want to stay with. There's so many different factors, and there's really there's no answer that works for everybody. But I think that what you gave are some things to consider, and I know it's going to be helpful for folks that are listening in.
Yeah.
Oh, that's great. And that you said you thought about the PhD. I mean, what are your thoughts there? And I guess this could vary depending on, if somebody's working for a contractor, a GC, a consultant. But what do you think? Is a PhD required to have a successful career? Now I know you and I don't have PhDs, and I'd like to believe that you and I have successful careers. But what are your thoughts there? What does a PhD do for you? Why would somebody consider? What are your thoughts there?
The PhD, I think, gets you kind of even more personal. If you want to go into academia, PhD, that's your route. You got to do it. If you're looking at going, into practice, I think what sometimes people might be disappointed to find is that say you spend 4 or 5 years working on your PhD, I don't think that always translates. If a company is looking at trying to hire somebody with 4 or 5 years of experience, and that's somebody 4 or 5 years in practice versus somebody with 4 or 5 years of a PhD, I don't think those credits really translate one to one necessarily. So that's kind of something to keep in mind, just maybe to avoid some disappointment down the road. If there's a project that comes up and you are very interested in it and passionate about it, I think you kind of have to take it on its merits. Don't look at the PhD as some title that's going to open a lot of doors for you. If you have a project that's specific to a certain industry, or maybe even a certain company, that may be significantly very beneficial to you. On the other hand, if you do a PhD and you become the absolute expert in that field as the end of result, maybe it does pan out in your favor at the end of it, and you can negotiate based on that down the road. But I think it all comes back to the project. Sometimes I think people end up doing something that's just very super niche, and it just doesn't necessarily translate to great real world experience. And that might be a little bit of a letdown. But other times it does give you the how to do research perspective. So I would say go for the project you have. Don't go for the title.
Makes sense. And I think that when you're going for, and I think that's the challenge for a PhD student. I mean, this could be somebody, I mean, ages varies, but I mean, somebody could be starting a PhD as early 20s, right? And, they're taking on this opportunity, they're taking the classes, and, the name whatever grant giving organization, right? And it's like, this is something very specific for something that they need, but whether or not it's going to impact the greater of the industry, the student doesn't know at that point, right? He doesn't know. So, if you are able to do an internship, if you're able to do some type of shadow, it does provide you a glimpse of what you could do with this degree, right? Like if you're studying, I don't know, permafrost or something like that, but then you end up working in Miami, it's kind of like, my research is not applicable for where I am. So I think that you're right. It's a challenge. It's an opportunity, but you want to manage the expectations. You want to manage the expectations for wherever it is that you land. All right, great. So let's talk a little bit about let's say short-term and long-term benefits for obtaining a graduate degree. in geotechnical engineering. So you think about in your experience, what are some of the immediate benefits that graduates can expect after completing their degree? And what are some of the longer term benefits that can help shape their career for having because they had a graduate level degree in geotech?
Yeah, on the short term side, I think, especially if you're really doing like geotechnical engineering as opposed to kind of, I'll say sometimes people, you get stuck out behind a drill rig for a year or two. It's probably not going to benefit that as much. But if not that that's not good experience, because it is, but if you're kind of in the office doing engineering and that kind of thing, you'll make connections a lot faster, I think, than what you would with an undergrad degree. Because I'll give an example. Maybe you're doing something and some pile design. Let's just say it's a bridge apartment, something like that, and you're doing pile design, and then there's going to be a bunch of fill that goes in after the piles are installed. If you had a decent grad program and you kind of went through a deep foundations class, you're probably immediately going to be like, hey, down drag is going to be a problem here. If you didn't do that, there's a good chance you don't know what down drag is coming out of an undergrad program. Yeah. Hopefully the engineer you're working for is guiding you through that, says, hey, this is the type of issue we have to look at here. But again, you're really reliant on that specific person. And, they're a PE, presumably they're competent and all that, but it's you have to be aware that they're a person. They have the experiences they've had. So now you're that's your person. That's who a lot of what is tied to. Whereas if you have all that graduate background, you can pull from that, make those connections. And you're not going to get a super in-depth knowledge of everything from a deep foundations class or a soil mechanics class, but you'll kind of get maybe little seeds of different, much more detailed topics that you can always go back to. I mean, I've got incredibly, detailed notes that I rewrote from grad school 3 or 4 times going through and studying stuff. And you hopefully can kind of go back to those and be like, hey, I don't remember all the details, but like I remember like down drag was a thing and fill can cause it. So like, all right, let me go back to those. And you can do that a year, 2, 3 years later. And on the long-term side, I think what's happened in my career a bit is you're not going to be able to develop that super deep knowledge base in 18 months or 2 years in grad school, right? But if every time one of those topics comes up, you go back to it, you start at kind of what you knew, and then you're like, all right, I had a note here about liquefaction potential. There's something jotted down here about Baez and Martin. That's a paper. Let me go find that. And then, you spend a day or two digging into that and getting a little more knowledge. If you do that for this topic and that topic and this topic over, every few months over the span of 5-10 years, now you're building a really, really deep, broad knowledge base that you can apply, and I think it just compounds over time if you can kind of, have that starting point.
Yeah, I think that's, I agree. I think that, there's this notion when you graduate, whether it's undergrad or graduate school, you're like, oh, I don't have to study anymore. But I think that as engineers and especially as geotechnical engineers, you kind of have to get rid of that. Like we're still studying.
Unfortunately,
we're still practicing engineering, right? We're still learning. And I like what you said that, going back to those technical papers, going back to really going to conferences, learning about recent case histories and delving in deep, right? So it's like we have to remain curious in order to remain valuable for whatever it is that we're doing within the world of geotechnical engineering. Yeah. So no, that's good with the short term and the long term. So some may argue the cost, right? I mean, grad school is not cheap, right? Mm-hmm. But some may argue that the cost for a graduate degree might not be worth it because they're considering a return on investment. What would you say to those that are hesitant to, pursue a specialized degree because of the financial concerns? What are some things you'd say to them?
Yeah, so I don't want to downplay that because that is very significant. And it's one thing if you just say, maybe you had funding for your undergrad and you're just kind of doing graduate school out of pocket or some combination of the two. But if you already have, it's possible you're already looking at substantial student loans from undergrad and now you're adding a graduate program on top of that can be significant. And I don't think there's any one answer for any one person. The getting to work is the quickest way where you can kind of start paying those off. I think generally if you come out of a graduate program with a specialization in geotechnical engineering, we're we're not the tippy top of engineering, compensation wise. We're not, I don't know who is anymore, petroleum or mechanical or something like that, probably. Um, but I don't think there are going to be exceptions to this, but broadly, I don't think you're not going to be poorly paid. You're generally going to have a decent compensation package. And especially if you have that graduate degree, there's a network that goes with it for one thing that, for example, at Virginia Tech, or if you went to Georgia Tech or wherever, the previous graduates from those programs are kind of probably more likely to hire you. Then you can kind of tap into that network and hopefully maybe get a little bit, better compensation package down the road. So I think, it could be substantial, and that's something you kind of have to think about. But in general, I think you should end up somewhere where you can kind of hopefully make those student loan payments without it being too much of a burden down the road. It might take a few years, but for me, I mean, I didn't have funding for my grad degree, and I would say it was very worth it in the long term.
Yeah. Yeah, I agree with you. I think that, if people are looking at the cost of grad school and they're looking at starting salary for a bachelor's versus 18 months later come up with the grad school, it might not make sense numbers wise. You might say, hey, wait, look at the cost of my degree. But I think that when you think about the if you were to plot it out, right, the asymptote versus if you still have a greater trajectory because you have that master's degree and the doors that it opens, I think there definitely is a return on investment, especially for geotechnical engineering. Because when you think about what you learn in undergrad, you're really not taking a lot. You're not scratching the surface, right? You're not really doing much. Even if you're at the best undergraduate schools, you don't have enough time to take the graduate level classes. So all right, cool. So for those that are listening and think that all right, so you get your grad school and you still have to study. Yes, you still have to learn. Then you get the PE, which could be a whole episode in by itself. But we'll just we're fast forward. We had the education, we have the PE. So now you have to get continuing education. So talk to us a little bit more about continuing education in the field of geotechnical engineering. Would you say that obtaining a graduate degree is just the beginning of a lifelong learning journey in this field? Is that the way we would think about it?
Absolutely. Yeah. This is probably where I get myself into a little bit of trouble, honestly. The continuing education as a concept, yes, like you want to keep doing it. You want to always try to be kind of getting better and learning more because, again, this is something I don't think I had any sense of even coming out of graduate school, is just the body of research on any number of topics that's out there. Honestly, like I've been, practicing for 10 years now, and there's stuff that I will think I have a pretty detailed understanding of, like all the different aspects of pile capacity. We'll just stick with pile capacity. A lot of people think Davison's failure criteria. But there's other methods of determining pile capacity that have pros and cons. And that's something that there are probably people with 20 years of experience out there that don't really know that. Yeah. And the only way you're going to pick that up is continuing education. Where I'll get myself into trouble is I think PDHs and the way that those systems aren't always the best continuing education.
Yeah.
There are a lot of PDHs I have from a lunch and learn or whatever, where it's like you go and it's kind of an interesting thing and you get a credit hour for it, but then you don't apply it. It's something completely outside of what you do. And you've forgotten about that in a month, maybe. Yeah. But on the other hand, you might be doing self-study looking at, I've got 3 papers in front of me right now on, different things. And that might be something you're doing self-study for like an afternoon, like hours that you don't really take credit for on any sort of, continuing education thing for a state board or anything. But that to me is where the more of the value is when you're doing that kind of stuff. Yeah. Certainly industry specific conferences, Geo Congress or DFI, the stuff that's really specific to kind of what you're doing and what you're interested in. If it's something that's like just really off the wall, is an example for me, like some kind of like LiDAR remote sensing thing for like landslides. Like that's interesting. It's good to know it's there. I'm not going to do it or use it. It's so far outside of what I do. But when you can kind of, see things that are close enough to what you do that you can apply them or try to apply them at least. that's huge, and that's really important to stay on top of.
Oh, that's great. And it just continues. You never get to the point where you say, all right, I'm done. I know it all.
No, I thought that was going to be the case after the PE, and I was very wrong.
Yeah. I've been doing it for 20 years and I'm still like, nope, I'm still learning every day. So
like, one of these days, can I be done? Can I just put all these books in a closet? And it's like, that's retirement, right?
That's retirement. That's retirement.
Yeah.
All right, great. Well, before we take our break, final piece of advice you'd like to give people that are listening in or watching that might be considering a graduate degree in geotechnical engineering. What are some of the key factors that they should consider before making that decision to enroll in a grad program? What would you say for them?
I think the big thing is what do you want out of it? Very practically. And I think that's something that I did not think about, to be honest, when I was going to grad school. For me, it was, hey, it's March. I don't have, many job offers yet, or, the interview set up, and graduation's coming up real quick. Like, job market's not where I'd like it to be. And, I just, was like, all right, I'll go to grad school. We'll punt this issue for 2 years. But I think the thing that I wish I had done was treat grad school more like a job. Because I think it's very easy to kind of, especially if you go straight from undergrad into grad school, sort of still take that sort of college student mindset, I guess I'll say, where it's like, it's about this homework assignment or this test or, this thing, as opposed to, let me really get into and understand these topics. I think that's how you're going to get the most value of it, is kind of, it's a real change in mindset to be like, this is my career. This is what I'm trying to pursue. I just want to know as much as I can about it and really understand these topics, not for the sake of passing this test, not for the sake of getting this homework assignment in, but because I want to understand the topic, because it's an interesting stuff with a lot of meat to it that will be very applicable down the road. It's tricky because you haven't worked yet to be able to say this will be very applicable down the road. But if you're listening to this, I'll tell you with hindsight, it will be very applicable down the road. And take it seriously.
That's great. That's great. Well, thank you so much. That's a good note for us to pause on. We're going to come back in just a minute and close this one out in our career factor safety in segment. Stick around. But actually, before we do that, we're going to have a quick word from our sponsor, PPI.
Before we dive in, we'd like to recognize our sponsor for this episode, PPI, a leader in engineering exam prep for the FE and PE exams. PPI provides expert prep courses and study resources designed to help you pass the FE and PE exams the first time. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. Check out PPI today at ppi2pass.com to see all the options available for FE and PE exam prep. Now let's dive into today's episode.
All right, welcome back. It's time for our career factor safety in segment. So in geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But the question is, what about incorporating a factor of safety into your career? So today, of course, we're speaking with John Myers from Menard, USA. And John, you've already had a very successful career. Again, you're still in your career. But when you look back at your career, what's something that you've implemented in your career to give yourself, let's call it a factor of safety in your career?
Yeah, I don't know that it's anything I ever, intentionally thought about at any point, but it is something I've kind of noticed that I maybe sort of let myself do, or I don't know, give myself permission to do if it's but I think a lot of times what people will have happen on projects is you'll have some kind of issue pop up that's maybe a little bit new, and you know how to approach it, generally, but doing like a deep dive may not be immediately beneficial to that project. Like, you may have done something good enough to get an answer and advance that project. Mm-hmm. But you kind of look at something, you're like, all right, yeah, I got an answer on this project, but this type of issue could come up on any number of projects. And, kind of, even if it takes a little more time, if you're really on a really tight deadline, you can't do it. But if you have a little bit of time to kind of get into something and I'd say go down a rabbit hole a little bit. An example might be if there's some kind of, internal process for a calculation that, people get into work, and it's, somebody's handwritten notes from the last time they did a design or something like that. And that's good enough to kind of get you through a project as long as you understand the gist of it. But if you see a reference to like, reference PTI manual, whatever in something, and you're like, I'm gonna go read that. I'm gonna dig into it and figure out what the source thing for that was. And you'd be surprised the kind of the nuggets you find and stuff like that, because you might find something that is, hey, there's this footnote like in this code document that says like, in this case, you don't have to do this. And unless you get into the weeds on that, you're not going to know it. You might have completed that project, but that type of stuff, if you kind of give yourself the space and the permission to do that a little bit, I think long term you kind of see that sort of stuff compound.
That's great. Yeah, I've found that you go through the code and then go through the commentary, understand why things are in there, right? And those the special cases are so important to understand. So thank you for that.
Yeah, an example, we had a project a while back that it was like a calculation that took like a really code-based value. And I talked to I reached out to an old professor about it, because I was like, hey, like I'm just getting crazy results. It was something related to ground displacement during seismic stuff. And there's a way you can just calculate it. And, I had a call with them, and it was like, yeah, that's just the value that got picked for the code. But like, if you were there for the code committee meeting, like I was, wow, there was a lot of debate about how realistic those value was. And they just came up with the most conservative thing. He's like, but I would do this and recommend doing this value. And you're like, oh, this makes a big difference.
Yeah. Wow. It's good to make that call, right?
Yeah, but if you just kind of take that.
Because you went to grad school, you felt comfortable making that call. There it is.
Credit to Dr. Green at Virginia Tech.
Love it, love it, love it. Well, John, thank you so much for coming on and sharing all the great insights with us. You share some great information and advice that I know is going to be helpful for our listeners and those watching. If somebody wanted to reach out to you, what's the best way for them to get you? You have an email you want to share, or are you on social media?
I don't really do the social media thing a ton, but they can reach out to me at via email. It's jmyers at menardusa.com, or just check out the Menard website. I don't think I'm listed on there specifically, but if you get a hold of anybody in the Southeast or most of the company, they'll know where I am and be able to track me down too.
Excellent. Well, thank you so much. Have a great day.
Yeah, thanks, Jared.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 73, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all of your geotechnical engineering endeavors. Peace.